Dear students, welcome back. The topic of this lecture is calculation of volume of a 3D solid of revolution by the method of disk. To do that, first it is important to know what is a solid of revolution because it is related to the shape of the solid. A solid of revolution is a solid that is created by revolving a plane region about a line, and the line is called axis of revolution. For example, if you revolve this plane region about its axis of revolution, means about this line, then you will get a solid right circular cylinder like this. If you revolve with this line, and if you revolve this plane region about this line, you will get a solid sphere. And if you revolve this plane region about this line, then you will get a solid cone. And if you revolve this region about this line, you see this region is a bit away from this line. So if you revolve this region about this line, then you will get a hollowed right circular cylinder like this. There is an empty interior inside this cylinder. So you see the difference. These are the solid materials, completely solid, there is no empty interior. In this case, you need to use method of disk to calculate volume. And if there is some empty interior inside the solid, in that case you need to use method of washers to calculate its volume, because you need to subtract the volume of this empty interior. So it is called method of washers. So now let us try to understand how can we calculate volume by the method of disk. Before that, let me tell you, if you take a cross section here like this, then this cross section will be circular. The shape of this cross section will be circular, and that's the reason this method is called method of disk. And every cross section will be circular. So all cross section, the area of all cross section will be pi r square, pi into radius square. So you see, if you revolve this region, this plane region from x equal to a to x equal to b about x axis, then you will get a solid material like this. And in that case, you can take a cross section like this. Okay, and this cross section is perpendicular to the x axis. So if the cross section is perpendicular to the x axis, and you see the width of your cross section is dx, so in that case your formula will be this one, volume formula 1, which is where we will integrate the area of this cross section, and the area of this cross section from one end to another end, and the area of this cross section will be pi r square. And here r means this distance, it means this distance. At x equal to x, the radius is fx, the radius of this circular disc is fx. So the area will be pi into fx square. Therefore the area formula integrating with respect to x will be pi fx square dx. So we will use this method only when the cross section is perpendicular to the x-axis. And in case of formula 2, you see, if you revolve this plane region about y-axis from y equal, let's say, c to y equal d, then you will get a solid material like this. It's a rough sketch, and cross section is perpendicular to the y-axis, and radius of cross section will be x, which is fy. So the area of this circular cross section will be pi r square, and here r means fy square. So the volume formula 2 will be y equal to c, y equal to d, pi fy square dy. And we will use this method only when the cross section is perpendicular to the y-axis. So please remember that we will use formula 1 when the cross section is perpendicular to the x-axis, and we will use volume formula 2 integrating with respect to y only when the cross section is perpendicular to the y-axis. So now let us try to solve some examples. Example 1, it says find the volume of the solid that is obtained when the region under the curve y equal to root x over this interval is revolved about the x-axis. So here our curve y equal to root x is like this curve y equal to root x, this is our axis. So if you revolve this curve over the interval 1 to 4, let's say 1 is here, 2, 3, 4. So if you revolve this region from x equal to 1 is here and x equal to 4 is here about x-axis, then you will get a 3D solid material like this. It will look like this. And now if you take a cross section here, a circular cross section, this cross section will be perpendicular to the x-axis. So we need to use volume formula 1. It means x equal a to x equal b pi fx square dx. So this means x start from 1 and end at 4. Pi you can take out of integration, and fx is nothing but this, because y equal to fx is equal root x. So root x square dx, and this equal pi integration from 1 to 4 x dx, and this equal x square by 2 integration of x equal x square by 2. So if you put the upper limit, you will get 16 by 2 minus 1 by 2, which is equal 15 pi by 2. So 15 pi by 2 is the volume of this solid material. Now let us try to solve example 2. It says derive the formula for the volume of a sphere of radius k So you can only find a sphere of radius r if you revolve the upper semicircular region and x-axis. So if you revolve this plane region about x-axis, then you will get a sphere like this. This is our 3D sphere. So, and the equation of this semicircle is of radius k is x square plus y square equal k square. So from here we can easily calculate y equal k square minus x square root. We considered only the positive one because this is upper semicircle. So if you revolve this region about x-axis, then your and consider a cross section here. Like here, this cross section will perpendicular to the x-axis. So our volume formula will be the first one. X equal a to x equal b by fx square dx, and here at this point k equal x equal minus k, and at this point x equal k. So you need to integrate from minus k to k, and pi you can put out of integration sign, and fx is nothing but this one, root k square minus x square whole square dx. So this one and this one will cancel. Therefore we can write integration of k square is equal k square x minus integration of x square x cube by 3 minus k to k. So this equal pi k cube minus k cube by 3 plus k cube minus k cube by 3. So this equal pi into 2k cube minus 2k cube by 3, which is equal pi into 3 6k cube minus 2k cube. So let me take it here, or let me write it here. So this equal pi 6k cube minus 2k cube, 4k cube by 3, 4k cube by 3. So we can write it in a standard form, 4 by 3 pi k cube. So the volume of a sphere of radius k is 4 by 3 pi k cube. If the radius is r, then it will be 4 by 3 pi r cube. So now let us try to solve example 3. It says find the volume of a solid which is generated when the region enclosed by y equal to root x. So here y equal to root x, y equal to 2 and x equal to 0. This is bounded by these three lines. So let me graph it. The first one is y equal to root x, and second one y equal to 2. So let's say 1 2 here, 1 2, y equal to this one y equal root x, and x equal to 0. X equal 0 means y-axis. So this region is revolved about y-axis. If you revolve this region about y-axis, then you will get a 3D solid like this. You will get a 3D solid like this. So it will be like this. So and if you take a cross section here, this cross section will be perpendicular to the y-axis. So we need to use our volume formula 2, which is y equal to c to y equal d pi f y square dy, and here y start at 0, y equal to 0 here, and end at y equal to 2. So the lower limit will be 0 and upper limit will be 2 pi fy, and fy means radius, and which is radius of this solid. It means this distance, and which is nothing but x equal fy, and this x is equal from here x equal y square. So from here I can write x equal y square. So my radius is y square, whole square dy, and this equal pi y to the power 4 integration from 0 to 2 dy, and this equal pi y to the power 5 by 5 0 to 2, which is equal pi by 5 2 to the power 5 minus 0, which is equal 2 to the power 5 equals 32. So 32 pi by 5 is the answer. So this is the volume of this solid. Now let us try to understand example 4. It says find the volume of the solid generated by revolving the region which is bounded by y equal to x square and x-axis over the interval -2 to 4 about the x-axis. So how can we do that? So let us first try to graph. This is our x-axis, this one is our y-axis. So if you graph y equal to x square, it will be like this. Okay, and from -2 to 4, 1, 2, -2 is here, 1, 2, 3, 4 is here. So let me draw it like this way. So you need to calculate volume of a solid if you revolve this region about x-axis. So if you revolve this region from -2 to 4 about x-axis, then you will find a 3D solid like this. So it will like this. This is a rough sketch. And now if you take a cross section here, this cross section will perpendicular to the x-axis. So we need to use our volume formula 1, which is x equal a, x equal b pi fx square dx. So here the lower limit is minus 2, upper limit 4, and pi you can put out of integration sign, and fx y equal x square. So fx equal x square whole square. Fx is the radius, which is this. This is the radius. At x equal x, the radius is fx. So this equal pi x to the power 4 integration from minus 2 to 4 dx, which is equal x to the power 5 by 5 minus 2 to 4 pi, which is equal pi by 5, 4 to the power 5 plus, because there is you will get a minus here, so minus 1 minus will be plus 2 to the power 5, 1056 pi by 5. So this is the volume of this solid material from minus 2 to 4.